So we got all these kids here, and more than 2,000 teams around the world that are competing in an engineering design competition. So they have 7 weeks to design and build these robots. It looks impossible at the start, but they're all successful. And so they've learned what the game challenge is. You know, they have to hang these tubes on these pegs. At the end of the game, they have these little robots up the tower and score extra points. So they get the rules in January, and they also get a basic kit of parts. So that kit includes things like some of the motors, a few of the sensors, and the computer, the kind of the brain of these robots. But then the kids, they get to decide what else goes along with that. You know, consistent with the rules, but you see all these different designs out here, so they go out and buy different materials, fabricate them different ways, they use different tools. So the baseline is the same, yeah, the basic things that they use, but then they go way beyond that. So they had to design and build and program these robots to pick up these tubes. So there's these different colored tubes, and they're different shapes, and if they put them in the right order, they get more points. The higher the tubes are posted up there, the higher the point score. And then if they get them in the right order, triangle, circle, square, then it doubles everything. And at the beginning of the match, they have these special yellow tubes. And at the first 15 seconds of the match, the robots are on their own. It's all the intelligence that's programmed in the robot to take that yellow tube, find the right peg, and hang it up there all by themselves. And the kids take over, and they have 2 minutes to do their thing and try to do the best they can. And it's also 3 teams together, so it's 3 on 3, and they come out here and they've never worked with these teams before, so they've got to figure out their strategy at the beginning too. What are you good at? What am I good at? Okay, this is what we're going to do. We really view this as the future of NASA, the future of our country, the contractors that work with us. We've got to have a talent pool to do the difficult things that are, you know, on our plate, the challenges we're going to face. And so NASA's heavily involved in competitions like FIRST. You know, this isn't the only one, but this is a good example. So we're involved on a lot of different levels. You know, we provide some funding just to get teams started. Something like this was really kind of a, you know, university level design project. It takes some money. They're out there working with real materials, real machines, and so they have to pay for that. NASA provides mentors. So scientists and engineers and technicians that are working on NASA missions are also working with these kids in their high schools and in their communities to come up with the designs, to teach them what engineering is all about, and then to actually help them do the building, the machining, the programming, and the testing. So there's really a lot of different levels that we're involved with, just because it really is such a big part of what our future needs to be.